Hey, welcome to our 4.3 lesson on factoring quadratic functions. So if you're factoring, remember what we want to look for is we want to find multiples of this number that will add up to that number. So if you wanted to, you could simply break down 12. It'd be 1 and 12 are factors, 12 and 1, 2 and 6, 6 and 2, 3 and 4, and 4 and 3. All right. So when it's all positive, you really don't need to worry about the second ones like this. So it's just between those three. And clearly these are the two that add up to 7. So then my factors would be y equals x plus 3 and x plus 4. Those are my factors. So I factored the 12 and I factored x squared. So notice x squared became x, and 12 became the 3 and the 4. And what I would do to check is I would FOIL. Remember our process of FOIL, and I would multiply it out and it would work out to that. And then the next one I do the same concept, where only now I'm looking at the negative 18. Okay, so it's a negative 18. So I could do negative 1 and 18, negative 18 and 1, negative 2 and 9, negative 9 and 2, negative 3 and 6, or negative 6 and 3. And in this case, I'm looking to find two numbers that would add up to 3x. In this case, because it's got to be a positive 3, I'm going to use these two right there. So then I would write y equals, again, I broke x squared down into x and x, and then I would put a minus 3 and a positive 6. All right, there it is factored. On the next one, we would take a look at, in this case, notice it's really like having a plus 0 back there. So I could have 0, right? So what multiplies the 0 and would add to 5, all right? Well, in that case, think about it. Factors of 0 are 0 and 1, 0 and 2, 0 and 3, 0 and negative 5. But in this case, I could do 0 and 5, right? Or the other way you could look at it is I could just take just these two, and do those two have anything in common? Notice both of them have an x in it, all right? Well, if I did 0 and 5, I'd have y equals 2, and I took x squared and broke x squared into x and x, and it'd be x plus 0 and x plus 5. Well, really, x plus 0 is just x multiplied by x plus 5. That would be my new factored. And take a look at that. Notice if I took out an x, so think about it, reverse distributive property, I just took out what's called the greatest common factor. Notice if I take out that x, if I take out one x from this part, what would be left to be another x. And if I took out one x from this part, I'd be left with just the 5. So two ways you could look at that one. Either way, you'd get the same answer right there. Lastly, on this one, I have the negative 14. So it's a negative 14, so negative 1 and 14, negative 14 and 1, negative 2 and 7, or negative 7 and 2. And I need to add up to a negative 5. In that case, it would be this one. And again, I need to break it down, and I take my x squared, and I break that down, and I factor it as x and x, and then I would have a minus 7 and a plus 2. So then I've taken a factoring, all right, and what I'm going to do is I'm going to clean this up just a little bit so it's easier to see, all right? And think about what I have over here. Notice all of these ones here, these equations. Notice that's standard form. What do all of these over here look like? Notice those look like intercept form from last week. And here you can see it. This is standard form right there, and you can see these are in standard form, like ax squared plus bx plus c. And these ones here are looking like it's factored, but it's intercept form from our 4.2 work. So if you have standard form and you factor it, you end up getting intercept form. And remember, intercept form is great for finding x-intercepts. So on this one, I'd have x equals 7, or x would be -2. All right. And if those of you have been wondering why every time do we always say if it's x minus 7, do we make it a positive 7? If it's x plus 2, do we make it a -2? I will show you that today. Before I do, though, I want to get to a couple other special products here. So if you look here in standard form, we're still talking here. It's called a special product, and the first one is called a perfect square trinomial. All right, now a perfect square, think of what perfect square means to you. That's like 0, 1, 4, 9, 25, 16. Those are perfect squares. The word trinomial, that's a 3-term polynomial. So 1, 2, 3 different terms. So it's like a perfect square. Notice 4 is a perfect square, 5 is a perfect square. If you notice the middle term, 4x is a double of a number. Here is 10x. You can kind of think this is a perfect square trinomial. All right, and so what you could say is that's going to be x plus 2 quantity squared. All right, and this one down here would be y is equal to x minus 5 quantity squared. All right, and now if you don't see that right now, well, let's look at this. How would I what are multiples of 4 that will add to 4? Well, I would break up x squared, like I have been, x and x. And then what multiplies the 4 and adds the 4 would be a 2 and a 2. So notice I end up with the exact same factor twice, which means I could write it as a one of them squared. Same thing on this one. What multiplies the 25, but would add to -10. Right? Well, think about it. You could do 5 and 5 or 1 and 25. But if it's got to add to a negative, I'd have to do -5, -5, or -1 and -25. So I would have x minus 5 and x minus 5. So same factor twice could be written as one factor squared, right? If you don't do these every time, if you don't spend the time to memorize perfect square trinomials, you will absolutely be just fine factoring like I did on the other slides earlier. But if you can do perfect square trinomials, that's a shortcut that would make things a little easier. Our second name is called difference of squares. All right, and I'm not sure why I didn't write these as y equals. Now this one is a little easier to see. Difference indicating subtraction, and squares, meaning I have to have 2 squares. So notice I have x squared is a perfect square, and 81 is a perfect square. So if I have that, that's called the difference of 2 squares, all right? And you could factor that a little easier. That could be then y is equal to x minus 9, x plus 9, all right? So you could remember that formula and that pattern, all right? So down here, a little more complicated with the 4x squared, but notice 4 is a perfect square, 49 is a perfect square, so I could factor that to become 2x plus 7 and 2x minus 7, right? The other way to look at that is it's like having x squared plus 0x minus 81, and what would multiply to -81 but add to 0, and that would be a -9 and a +9, and then you have those two factors. So again, you could still factor it like every other trinomial like earlier in this lesson, or you could try to remember the difference of 2 squares. That's just a shortcut. Basically, if the slide you're looking at right now isn't necessary, it's just shortcuts that could make factoring easier. Now on this slide, we're going to get back to when x minus 7 is in parentheses, why do we use +7 as the x value? So remember, we had this equation that was factored. And to do this, we use what's called the zero product property, which states if AB, notice the operation is multiplication, if A times B is equal to 0, then A is equal to 0 or B is equal to 0, right? The only way you could multiply two numbers and have their product be 0 is if you multiplied by 0. Right? So on a problem I have here in front of you, y equals x minus 7 multiplied by x plus 2, what we were going to do is we were just going to kind of do the same thing. X minus 7 is like having a, so I made a equal to 0. So I'm going to write x minus 7 equals 0. And then I would solve that. To solve that, I would get x is equal to 7. And then I'm going to have x plus 2. That's going to be kind of like having a b, and I set b equal to 0. So then that's going to be x plus 2 equals 0. And then x is going to equal negative 2 when I solve. And so that is the solution to this equation. And now what I really did is one thing I made a mistake of is notice it had to be equal to 0. So y had to become 0. My mistake on that. So if y is 0 and x is 7, then I have an x-intercept 7, 0. And if y is 0 and x is negative 2, I have an x-intercept of negative 2, 0. So my instructions up here are solving. But if I'm solving, I'm setting the equation equal to 0, which means I'm finding x-intercepts. So here's this last step. Solutions to quadratic equations are also called x-intercepts, roots, or zeros. All right, x-intercepts make sense. I just kind of went through that example. Zeros should make sense. What is the x value making the equation 0? And roots is kind of that same idea, but it's just a different term. Another concept I want to discuss is, remember back when we were doing simple things like absolute value, remember we would have absolute value of y, x minus 7 plus 3. Or when we did cubics even, we did x minus 7 cubed plus 3, all right? Now remember that meant it went right 7. Here's another reason why. X minus 7 becomes 7 as a x value, and positive 7 is to the right of 0. So just one more connection from their past. So working here, what is the solution? We just have to use the zero product property, or ZPP. You want to abbreviate it. In this case, same idea. I have this case, notice they're already factored. So there's one factor. So the only way that I can multiply these two factors and have it equal 0 is if one of them is 0. So either x plus 5 equals 0 or x minus 1 equals 0. Well, in that case, then I would have x equals negative 5 or x equals 1. And that is, both their answers must be there. Or it means it's either at negative 5 or at negative 1. Or just like we did absolute value, you just can't be both at the same time. But it's both answers are required. Moving on to number 2. Now I need to factor it first. So I got to factor what factors of 15 would add to negative 16. So for 15, I could do 1 and 15. But to add up to a negative, I'd have to have negative 1 and negative 15. I could do negative 3 and negative 5. And clearly it's that first one. So it's going to be x minus 3 and x minus 5 equals 0. Now we go ahead and use our zero product property again. And I'm going to state the only way that this times this can equal 0 is either x minus 3 equals 0 or x minus 5 equals 0. Then I would have x is equal to 3 or x equals 5. All right, I do want to see, whenever you're having a solution like this, if this is my equation, I want to see your factors in the work before I see the answers, please. And on the last one, you can take a look here at this. If you see the difference of two squares, all right, then you got an easy factor. All right, that could be x minus 4, x plus 4, still equal to 0. If you don't see difference of two squares, you do x squared plus 0x minus 16. And now we got to factor 16, negative 16. So you do negative 1 and 16, negative 16 and 1, negative 2 and 8, negative 8 and 2, -4 and 4, or 4 and -4. And obviously it's this one or this one, really doesn't matter. They say you got to add to 0. And now again, once I have my factors, must see the factors, I then will take each factor, x minus 4 equals 0, which then gets me x equal to 4, or x plus 4 equals 0, so x equals -4 are my answers there. Reminder, when you do your work, I want to see the factors and the answers, please. A couple more examples here, and what's so different about these ones? Well, in this case, the x squared is all by itself, and the equation, the rest of it's on the other side. Now, remember, to find the zeros, or to find x-intercepts, or to find solutions, I must have the equation equal to 0 somehow. All right, now in my mind, I would leave x squared where it is, because I like having positive 1 out in front. And I'm going to move these things to the other side over there. So add 3x and subtract the 28. So those go away. So now I have 0 equals x squared plus 3x minus 28. And now I factor this. So what are factors in -28? Okay. Well, I would do -1 and 28, -2 and 14. Sorry, I could have -28 and 1. Obviously, it's not those two. -14 and 2. I could do -4 and 7, or 7 and -4, right? So it's one of these two, all right? And it's got to be this one because I need a positive 3. So I'd have x, so it's x minus 7, sorry, plus 7 and minus 4, still equal to 0. Don't forget about that part. Now is the part, again, now we take the zero product property. So what I would set that equal to 0, and I would set that equal to 0, sorry, equal to 0, or that equals 0, right? The only way that they can multiply is one of them 0. So then x is -7, or x equals 4. Those would be my answers. Number 5, this one on here. All right, well, maybe you don't like the order it's written in, so feel free to change it. X squared plus 9 equals 0. All right, now I mentioned difference of two squares, but notice that this has a plus sign right there, which means I can't use the difference of two squares. In this case, then, what are factors of 9? All right, and think about it. I got to add up to 0. X squared plus 0x plus 9 is equal to 0. All right, well, let's factor 9. I could do 1 and 9. I could do 3 and 3. All right, well, I could do -1 and -9, or -3 and -3. Those are my 4 options, really. Well, notice none of them will add up to 0. So if they can't add up to 0, I cannot factor it. So right now, I'm just going to write down that it is not factorable. Okay? Another word you could use is that means it is prime, like 7, because 7 only has factors of 1 and itself. All right, so you could say not factorable, or you could say the word prime. Key here, there's that no solution is not a correct answer. There is a solution, we'll learn it later, but for right now, it's just simply either not factorable or prime. You choose between those two words. All right, this is our last 2 examples. Now we're asked for what are the roots of the equation. Well, roots are just like having the word zeros, okay? So the only difference on these problems is you physically have to put 0 in the y spot, or g of x. Okay, that's all you have to do. So in this case, you're going to do, and I'm going to switch this one around. I like the order to be x squared plus x plus 30, and I want that to be equal to 0. So you see what I did in blue? All right, all you're doing is you're putting in the 0 into the spot where y would be. That's how you find roots. That's how you find zeros. and I'm going to do the exact same thing. All right, I had to change this number. I wrote 40, but it should be 48 right there. So what are factors of 48? They're going to add up to negative 16. Now, this is a positive 48, but I got to add to negative 16. The only way I can factor a positive that adds up to negative is if I have double negatives. All right, so clearly it's not going to be 1 and 48. It won't be negative 2 and negative 24. How about a negative 4 and negative 12? All right, there, that works right there. So I could write 0 equal to x minus 4 and x minus 12. Then the zero product property, I'll write x minus 4 equals 0. So x is 4, or x minus 12 equals 0. So x equals 12. Notice the process of what I'm doing on this slide is exactly the same as the last one. It's just asking a different question. The word root or 0 means the exact same thing as x-intercepts, the exact same thing as solve it. Right? And then let's go to this next one. Now I got to add up to 30. All right. Multiplies a 30 and adds up to a positive 1. And again, in this case, if I did 1 and 30, 2 and 15, 3 and 10, 5 and 6, none of them add up to positive 1. So in this case, I would say prime, because it doesn't have any factors. Although what I am going to do here is I'm going to make this a little bit different, and what I am going to do is I'm going to say I wanted this to be a negative 30, so I'm going to put a negative 30 in there. And now I would say negative, 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 negative. All right, well, or I would have then the other way, negative 1 and 30, negative 2 and 15, negative 3 and 10, negative 5 and 6. Now I have one that works, right? So if this was in your homework, you would have said prime and stopped. I did want to factor this one, so I made a mistake. In this case, I'm now going to say 0 is equal to x plus 6 and x minus 5. Oh, I did that in a different order. I had 5 first and 6 second, but that is not going to make a difference. I now will take and set the factors equal to 0. X plus 6 equals 0, or x minus 5 equals 0. So then here x is equal to negative 6, or x is equal to negative 5. There would be my roots of the equation. Those are the zeros of the equation. Those are the x-intercepts of the equation. And those are the solutions to the equation. You may be asking, why do I have 4 different terms to do the exact same thing? And I would say that's a great question. And I don't know the answer, but the ACT will throw these different 4 words at you, so you do need to know them. That might be the best answer I could come up with. So this slide is just simply if you want a step-by-step process. If you're a fan of someone that has steps, you can follow these 5 steps to set up an equation. You want to put the terms in decreasing degree order, so that's the x squared, then the x, then the constant. Find any GCF if possible, factor, set each factor equals 0, and then you solve. If you like steps, you have 5 steps right there to follow. Here's the assignment. It's 9 to 54. This means by 3s, so that means then 9, 12, 15, 18, etc. Or if you look at the assignment, I'll have those exact problems set up. Good luck. Have a great day.